Hello everyone, welcome to Apna Guruji, and in this video we are going to study about light energy, that is class ICSE Physics. And in this chapter we are going to discuss about the light energy. So in your 7th class you already studied about reflection of light, but in your 8th class you are going to focus on light refraction. So there is a difference between refraction and reflection. If you don't know what is the reflection of light, then you can see my previous videos where I have already studied make videos about reflection of light. So in this video we are going to study about refraction and speed of light. So first, do you know that what is light energy? So light is a source of energy that feels the sensation of vision, and कोई भी चीज को हम लोग तभी देख पाते हैं जब लाइट एनर्जी उसके ऊपर गिरता है, देन गेट रिफ्लेक्टेड बैक टू आवर आइज, देन वी कैन सी दैट ऑब्जेक्ट. सो लाइट इज एनर्जी दैट फील द सेंसेशन ऑफ vision. Then comes to the topic refraction of and speed of light. So before that I want to tell you about the reflection of light. So in reflection of light, what happens, that whenever the rays of light fall upon a smooth or polished surface, it get bounced back to the same medium after striking on the smooth surface. That phenomenon is known as reflection of light. But in case of refraction, the rays of light goes from one medium to another medium. So here the medium will be transparent medium. So when it goes from one medium to another medium, then the rays of light get bent slightly. That bending of light is known as refraction of light. So you can see there is a lemon, and when we put the lemon inside a glass having water, so lemon size will appear to be bigger. So this is the reason due to the refraction of light. The phenomenon of bending of light as it travel from one medium to another medium is known as refraction of light. So the phenomenon of bending of light, it will depends upon the medium. So if the medium will vary, the bending also vary. So here suppose this is a medium that is low refractive index medium, and that is a higher medium or higher denser medium. So when the rays of light falls upon that surface, if it is goes from rarer medium to denser medium, then it bends towards the normal. So normal is that point of imaginary line where the rays of light incident, if you draw perpendicular at the point of contact, that imaginary ray will be your normal. So as for a normal consequences, the incident ray will go like this, but if the medium is denser than this medium, that's why it bends towards the normal. If the rays of light goes from denser medium to rarer medium, then it bends away from the normal. So here it is going from low refractive index to high refractive index, that's why it bends towards the normal. So this ray will be called as incident ray, and this ray will be called as refracted ray, and the imaginary line at the point of incidence is known as normal ray. So the angle between the incident ray and the normal ray is known as the angle of incidence, and the angle between the normal ray and the refracted ray is known as angle of refraction or refracted angle. So in the previous case we have already show that if it is goes from rarer medium to denser medium, it bends towards the normal. But in this, when there is the higher refractive index medium and lower is the lower refractive index, so it is goes from higher medium to lower medium. So in this case it generally goes like this, but it is going from the higher to rarer, that's why it bends away from the normal. So you can observe two medium here. So these are your incident ray, reflected ray, and incident angle and refracted angle, and this is your glass, that is denser medium, and that is rarer medium. So in this case, if the rays of light incident on this, so it partially reflected also. Partial reflection of refraction of light, that the boundary of two medium. Case 1, reflection from rarer to denser medium. When the air incident on the air medium to the glass medium, you can see that partially reflected also. When light travels from rarer to denser medium, suppose from air to glass, the partially refracted light bends toward the normal, and partially reflected light returns back to the same medium. So here partially bends, and the remainder of rays of light will reflected. Refraction from denser to rarer medium. In this case, you can see here also, when the light travels from denser to rarer medium, suppose from glass to air, the partially refracted light bends away from the normal, and partially reflected light returns back to the same medium. So main summary is that when it goes from rarer to denser, that is bends towards the normal, and when it goes denser to rarer, then it bends away from the normal. Effects. Speed of light in partially reflected light. In case of reflected light, that will be no change, but in case of refraction, speed of light will decrease in case of rarer to denser, and if it goes from denser to rarer, then will increase. frequency of light, there is be no change in frequency light, but in case of wavelength of light, if it goes from rarer to denser, then it will be decreases, and when it goes from denser to rarer, it will be increases. Simply we can say that when the light speed of light increases, decreases, the wavelength also decreases, and when it increases, the wavelength of light also increases, because wavelength of light is directly proportional to the speed of light. That's why it is. So wavelength of one decrease, but in this case increase. Then speed of light changes in speed when it enters from one medium to another medium. So when it goes from one medium to another medium, the speed of light will change. So in case of air, the speed of light or velocity will be 3 into 10 to the power 8 meter per second. In case of water, that is 2.25 into 10 to the power 8 meter per second. So air speed is changing. In case of glass, it is very low, that is 1.8 to 10 to the power 8 meter per second. So there will be a refractive index. The extent bending of light depends on the refractive index, to which medium that light is traveling. So the refractive index is given by the symbol mu. Is a medium is defined as the ratio of the speed of light in vacuum to that medium. So refractive index will be mu equals to speed of light in vacuum by speed of light in the medium. So this is by we can denote the refractive index. This refractive index of light depends upon three factors, that is nature of the medium, temperature of the medium, and wavelength of the light used. Then this is a relation. So there is a plant, there is a frog, the frog is inside the water, the grasshopper is looking towards the frog. So there is the grasshopper in the grass and there is the frog. In case the light is traveling from air to water, the refractive index mu is mu1 is less than the water mu2, therefore light gets slightly bends toward the normal, hence the frog appears closer the grasshopper. But in case of 2, the frog is looking towards the grasshopper. In this case, light is traveling from denser to rarer medium. As the refractive index of water mu2 is greater than the air mu1, therefore light will bend away from the normal. Hence the grasshopper appears farther from the frog. So in two cases, the two animals or two objects are looking each other, but due to the refraction of light, they seem differently. Then comes to law of refraction. There are two laws of refraction. The first law states that all the rays lies in the same plane, as like that in the laws of reflection also we have studied that the three rays of light lies in the same plane, like the incident ray, normal ray, and the refracted ray all lies in the same plane. This is the first law of refraction. And in the second law of refraction, that is also known as Sein's law, that is known as sin I by sin r equals to constant, that will be refractive index. So sin I means sin angle of incident angle, sin of refracted angle, that will be a constant. Here mu a b equals to the relative refractive index of the medium b with respect to medium a. So this is the refractive index of these two medium. So next there is an example. A ray of light incident on a glass surface is such a way that it makes an angle of 60 degree with normal. Determine the angle of refraction. So it are given mu is 1.34. So angle of incidence is I equals to 60. Angle of refraction we have to found. So using Sein's law we can put sin I by sin r equals to constant, that is given sin 60 by sin r equals to 1.34. So sin r equals to the sin 60 value will be root 3 by 2, that is root 3 by 2 multiply 1 by 1.34. So your sin r equals to 0.646. Then the relation between the refractive index of the medium and speed of light. So mu is the speed of light in the air by speed of light in the medium, that is c by v. So the relation between the refractive index and speed of light equals to mu equals to c by v. Effects of refraction. So there will some effect of refraction. So real and apparent depth. So in case of this, due to refraction, there will be a real depth and the apparent depth. Suppose this is a container, that is an object in bottom of the substance, and you are seeing above the container. So in this case, the real depth is total, but when you see due to the refraction, you will see the object in this position. So this depth is the apparent depth and the total depth is known as the real depth. So this is happened due to the refraction of light. So refractive index equals to real depth by apparent depth. You have to remember this formula, because when you are solving problems you will be using this formula. Then bending of sticks also, when you are put a stick on a container, so when you see above the container you will see the stick is looking like bending. So this is also due to the refraction of light. Then twinkle of stars also, So when we see a star in the sky, it will look like a twinkling because of the refraction, because there is a various layer of air, so denser to from the denser to rarer medium. That's why the rays of light get slightly bends, and that's why we can see that the star is twinkling. Raised beaker bottom, this is also due to refraction. I have explained before. Early sunrise and daily sunset, delay sunset, this is also due to the refraction light. Sun appears few minutes earlier before it actually rises above the horizon. Also, it is seen for few minutes longer after it actually sets. The cause of two phenomena is atmospheric refraction. So this is the example. When you see, the real position is this, but apparent position will be this. This is due to the refraction of light. Dispersion of white light in prism. So we know that there will be a refraction in case of rarer to denser medium. So when you use a prism, this is a refracting surface, this is a refracting edge, and this is also refracting surface. When the light will enter from this level, it goes from rarer to denser medium, and in this case it is going from denser to rarer medium. So in this case, the rays of light get refracted two times. So you can see there is a prism, so we will observe from this position, so we can see that the rays will get bended. So this is due to refraction. And if you don't particularly, so the rays of light goes from A position to B position, then this is the normal, so it is bends towards the normal, and it is bent like this, and from this position the rays of light goes from denser to rarer medium, that's it goes from away from the normal. So this deviation, the rays of light goes like this, but due to refraction of light, this is the bending of light. So this angle is known as the angle of deviation. In case of prism, we have to calculate the angle of deviation. The extent deviation of the light rays from its path B to path CD is known as the angle of deviation. Do you know what happens when you take light's incident ray instead of single ray? A beam of white light will split into bands of 7 colors. The splitting of beam of white light into 7 constituent colors when it passes from glasses of prism is called dispersion of light. So in case of the white light converts into 7 colors, that is known as the dispersion of light. This is due to the refraction, because when the white light consists of 7 colors, so when it goes to prisms, the different color spectrums have different wavelength and frequency. That's why different wavelength and different frequency get diverted into different angles. So that's why the white light will be dispersed into 7 colors. Can you say which color undergo maximum deviation with this example? Will answer. Please answer in the comment section. Formation of rainbow, this is also example where we sometimes in the rainy season we see rainbow in the sky. This is also due to the dispersion of light. When the rays of light from the sun falls on the ground, but it is, if it is raining at the time, so the rays of light goes through the water, and water will act like a prism actually, and that time the white light gets dispersed into 7 colors, and we can see that rainbow formation in the sky. Reflection of light, spherical mirrors. So this will be another topic. So I hope today we have to discuss about this, and in this reflection of spherical mirror is a big topic. We will explaining in the next video. So I hope you understand the refraction of light in this video. If you feel any doubts, then please ask in the comment section, and we will in the next video we'll be discussing about the refraction through the spherical mirror, and reflection by light by spherical mirrors, and doing the solving some numericals. So thank you guys for watching. If you feel in doubts, please ask in the comment section, and if you like and enjoy from the video and learn from the video, just please share with your friends. Thank you guys for watching. Keep watching Apna Guruji.